I am Professor Obiang. Once again, I welcome you to my class of mathematics. The topic for this session is known as calculus. We cannot say anything about calculus if we don't introduce first the concept of limits. The limit concept is essential to the study of calculus. In order to have an idea or an understanding of this concept, we will present an example on the board. F of x is equal to x squared plus 1. From algebra or from analytic geometry, we see that this function here, it represents a parabola which is parallel to the positive y-axis. Its graph will look like this. This is x-axis, this is y-axis, and at this point here, at point 1, or at point 0 and 1, at point 0 and 1, we have the vertex of this parabola. Suppose we choose an arbitrary point. Let's say this point here. Let's call this point here point 2, which means that when x is equal to 2, y is equal to 2 raised to the second power plus 1, which is equal to 4 plus 1, which gives us 5. Which means that this arbitrary point that we have chosen is 2 and 5. Now, the question arises in calculus. In calculus, or in limits theory, suppose we ask the following question, which is the question: what will happen to f of x, this function here, as x move closer to 2 from either side, from the left hand side or from the right hand side? I repeat again. The question is, what will happen to f of x when x move closer to 2, either from the left or from the right hand side? Okay, let's see it. I'm going to write a table here. Okay, from the left hand side, let's say here we have x, then f of x is equal to x squared plus 1. Then on the right hand side we have x, and f of x is equal to x squared plus 1. As I said, this is the left hand side and this is the right hand side. So let's say that this is point 1, point 1.5, point 1.9, point 1.95, and point 9.99, and point 9.99, and here we have point 3, and point 2.5, and point 2.1, and point 2.05, and point 2.01, and point 2.0001. Okay, let's give values here. What we're going to do is simply substituting for the value of x, 1, Here, when we substitute this value here, x, into this equation here, we will have 2. Here we will have 3.25. Here we'll have 4.61. Here we'll have 4.8025. Here we'll have 4.9601. Here we'll have 4.99600. On the right hand side, at x is equal to 3, we'll have f of x is equal to 10. Then 7.25, then 5.41, then 5.2025, then 5.0401, then 5.002. Again, I repeat my question again. What will happen to f of x when x moves closer to 2? Which means that from the left hand side, when x moves closer to 2, as we can see here, from 1.1.5 to 1.99, 1.99 is approximately equal to 2. So f of x moves closer to 4.99600, which is approximately equal to 5. Which means that when x moves closer to 2 from the left hand side, f of x moves closer to 5. Now from the right hand side, starting from 3 to 2, when x moves closer to 2, f of x moves closer to 5002, which is equal to 5. Again, x move from 1 to 2. As x moves closer to 2, f of x moves closer to 5. On the right hand side, the same thing happens. When x moves closer to 2, f of x moves closer to 5.00. Now, if this is so, then what we can say is this, that the limit as x approaches 2 of f of x is equal to the limit as x approaches 2 of x squared plus 1 is equal to 5. Look at it very carefully. So again, my question is, what will happen to f of x when x moves closer to 2? From the left hand side, when x moves closer to 2, f of x moves closer to 5, as we see here. From the right hand side, when x moves closer to 2, f of x moves closer to 5. So, theoretically, what we can say is this. If L is a real number and f of x is defined on an open interval containing a point which we might call x sub 0, not necessarily x sub 0 itself, then the limit as x approaches that point there, point x sub 0 of f of x, is equal to L, L being the limit. I repeat again. If L is a real number and f of x is defined on an open interval containing x sub 0, not necessarily x sub 0 itself, then the limit as x approaches x sub 0 of f of x is equal to L. From here, f of x must get close to L when x gets close to x sub 0 from either side. Let's give a few examples here. Okay, suppose, as an example, if I said the limit as x approaches 1 of x plus 1, so this limit here, as x approaches 1 of f of x being x plus 1, that will be equal to the limit as x approaches 1 of x plus the limit as x approaches 1 of 1, which is equal to 1 plus 1 is equal to 2. Okay, let me raise this board here. We are still raising the board, and then we will present a few properties of limits. Okay, let's see what happens to the limit of a polynomial function. Okay, as a polynomial function, suppose f of x is a polynomial function, and this polynomial function being, let's say, x sub 0 plus x1 plus x2 to the second power plus x sub 3 x raised to the third power plus x sub 4 x raised to the fourth power plus etc. plus x sub n x raised to the n power. Now let's assume this is the polynomial function. If the polynomial function is the following we see on the board, which is f of x is equal to x sub 0 plus x sub 1 x1 plus x sub 2 x2 plus x sub 3 x3 plus x sub 4 x4 plus etc. plus x sub n x to the n power. Then the limit as x approaches x sub 0 of f of x is equal to f of x sub 0, which is equal to x sub 0 plus a sub 1 x sub 0 plus x sub 2 x sub 0 raised to the second power plus x sub 3 x sub 0 raised to the third power plus x sub 4 x to the sub 0 raised to the 4th power plus etc 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 plus x sub n x sub 0 raised to the n power. Again, and I repeat, if x is the following polynomial function, if x is given as the following polynomial function, then the limit as x approaches x sub 0 of f of x is equal to f of x sub 0, which is equal to x sub 0 plus x sub 1 x sub 0 plus x plus 8 sub 2 x sub 0 x raised to the 2nd power plus x sub 3 x sub 0 raised to the 3rd power plus x sub 4 x sub 0 raised to the 4th power plus etc 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 plus x sub n x sub n sub 0 raised to the n power. As an example, okay, let's say the limit as x approaches 2 of x4 plus 3x3 minus 2x squared plus 1. Now this is equal to the limit as x approaches 2 of x4 plus 3 times the limit as x approaches 2 of x raised to the 3rd power minus 2 times the limit as x approaches 2 of x raised to the 2nd power plus the limit as x approaches 2 of n approaches 2 of 1. So the result here will be as x approaches 2 of x to the 4th power, that will be 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, plus 3 times 2 raised to the 3rd power minus 2 times 2 raised to the 2nd power plus 1. So this is equal to 3 times 8 minus 2 times 4 plus 1. This is equal to 16 plus 24 minus 8 plus 1. So this gives us 16 plus 24 is equal to 40 plus 1 is 41 minus 8 is equal to 33. So the limit as x approaches 2 of x to the 4th plus 3 times x to the 3rd minus 2 times x to the 2nd power plus 1 is equal to 33. Okay, suppose now, let's say we have f of x is equal to, or, okay, suppose f of x is equal to, or limit as x approaches x sub 0 of f of x Okay, let's do it like this. Suppose the limit as x approaches x sub 0 of a times f of x, a being a constant. So the limit of that is equal to a times the limit as x approaches x sub 0 of f of x. That is exactly what we did right here, like in this case, 3 times x to the third power. So the limit of 3 times x to the third power as x approaches any particular point x sub 0 will be solved like this, which we did already previously. Okay, let's repeat another example of the kind. Suppose we have the limit as x approaches 2 of 2 to the second power. So that will be 2 times the limit as x approaches 2 of x to the second power. So this is equal to 2 times 2 to the second power, which is equal to 2 times 4, which is equal to 8. Okay, repeating. Suppose we have a times f to the x, where a is any constant different from 0. Then the limit as x approaches x sub 0 of a times f to the x is equal to a times the limit as x approaches x sub 0 of f of x, such as in this example here. So the example will be like this one here. The limit as x approaches 2 of 2 times x to the second power, that will be 2 times the limit as x approaches 2 times x to the second power, which is equal to 2 times 2 raised to the second power, which is equal to 2 times 4, and the total will be 8. Okay, let me raise the board and see how do we solve the limit or the addition or the limit of the addition of two functions. Okay. Let's see. We are still raising the board. Okay, suppose we have two functions, f of x and g of x, and we want to find the limit. We want to find the limit as x approaches x sub 0 of f of x plus g of x. This one here will be equal to the limit as x approaches x sub 0 of f of x plus the limit as x approaches x sub 0 of g of x. Again, here we have two functions. Here we have two functions, f of x and g of x. F of x and g of x. And we want to find the limit as x approaches x sub 0 of f of x plus g of x. That will be equal to the limit as x approaches x sub 0 of f of x plus the limit as x approaches x sub 0 of g of x. As an example, Suppose we have f of x is equal to x times 2x squared plus 1 divided by x plus 3x squared. So the limit as x approaches, let's say 1 of f of x, that will be the limit as x approaches 1 of x times 2x squared plus 1 divided by x plus 3x squared. As we can see, before we make any move, we could cancel out these two x's, one in the denominator and the other one in the numerator. If we cancel out these two x's, we will have the limit as x approaches 1 of 2x squared plus 1 plus the limit as x approaches 1 of 3x squared. That was equal to 1 plus 1 plus 3 times 1 squared, which is equal to